In this video I want to solve between the pair of simultaneous equations 2x plus y equals 6 and x squared plus y squared equals 8. Now this is a linear equation, as you've seen in previous videos. It's got the form ax plus by equals c, where a, b and c are given values. For this equation a is actually 2, b is 1, c is 6. Now this equation here is not linear. It doesn't have this form. It involves x squared. It also involves y squared. A linear equation just involves x to the power 1 and y to the power 1. And it doesn't involve things like x times y. Now, the way we do this is we take the linear equation and make either x the subject or y the subject. I'm going to make y the subject of this equation because it's a little bit easier. So to do that, I subtract 2x from both sides, so I get y equals 6 minus 2x. If I was to make x the subject, I'd have this. I'd have x equals 6 minus y divided by 2. We have this fraction, which makes things a little bit awkward. So to do the algebra, it's easier to make y the subject of this particular equation. The next thing you do is you sub this equation into this equation here. So we sub it into the non-linear equation. We sub the linear equation into the non-linear equation. So we have to replace y in our non-linear equation with 6 minus 2x. So we're going to get x squared plus 6 minus 2x squared equals 8. We need brackets here, of course, because there are two terms. Y consists of two terms, and we have to square it. So now you see we have an equation with just one unknown, an equation involving x. This is going to end up as a quadratic equation. A quadratic equation has the form ax squared plus bx plus c equals 0. We'll have to get it into this form because you can see x squared is coming into this. So to get it into this form here, we need to open out these brackets. So we get x squared plus square 6 is 36. Multiply 6 by minus 2x and double. That's minus 12x times 2, or minus 24x. Then we square the second term. Minus 2x times minus 2x is plus 4x squared. Now to get it into this form, we want to have 0 on the right hand side. So this 8 has to be brought over. And we want to add up our x squared terms. So we get 5x squared. I'll write the x term down second. Okay, to get it into this form. X squared term is first, x term is second, constant term is third. The constant term is going to be 36 minus 8, which is plus 28. So now we have 0 on the right hand side after I brought over the 8. So now this is in the standard form of a quadratic equation. And we have to use the methods for solving quadratic equations. We have a formula which is minus b plus or minus the square root of b squared minus 4ac divided by 2a. So we apply our formula to this equation here. You can see that b is minus 24, the coefficient of x, and we have minus b, so we have minus minus 24, which is plus 24. Then we have plus or minus the square root of b squared, so we have to take minus 24 and square it. Then we have minus 4 times a times c. A is 5, c is plus 28. And all of this is divided by 2 times a, where a is 5. So you can go to your calculator, plug in what's inside the square root sign first. So we have minus 24 squared. Well, that's just the same as plus 24 squared. So when you square it, it's positive anyway, whether it's minus 24 or plus 24. Then we have minus 4 times 5 times 28. That gives us 16. We want the square root of this number. You could put this number to the power of a half to get the square root of it. Of course, you know the answer is 4. I'm just showing the quick way to get the square root. So we end up with 24 plus or minus 4 divided by 2 5s are 10. So we get two answers. If we take the plus sign here, we get 24 plus 4. That's 28 divided by 10. 28 divided by 10 is 2.8. Or if we take our minus sign here, we get 24 minus 4 is 20 divided by 10. 20 divided by 10 is 2. So what we found is two x values of actually two pairs of values that satisfy both of these equations simultaneously. The next thing we want are the corresponding y values. So we just use our linear equation. So if x equals 2.8, we get y equals 6 minus 2 times 2.8. That gives 0.4. Then we plug in our second value for x, which is 2, into this expression here. So we have y equals 6 minus 2 times 2. That's y equals 6 minus 4, which is 2. So what we get are 2 points. When x is equal to 2.8, we find that y is 0.4. When x is 2, we find that y is 2. So we have two pairs of numbers, or if you like, 2 points in coordinate geometry. Now I want to check that both of these pair of points satisfy our equations. You normally don't have to do this, but I just want to show you that everything is working out. So let's check the first pair. The first pair is x equals 2.8 and y equals 0.4. So we plug these numbers into each equation. So I'll start by plugging them into this equation here. So we get 2 times 2, well, I'll write it down first. 2x plus y is 2 times 2.8 plus y, which is 0.4. Hopefully this will work out to 6. 2 times 2.8 is 5.6. 5.6 plus 0.4 is indeed 6. Now we look at our second equation. X squared plus y squared equals 8. So I'll write out the left hand side of it. X squared plus y squared. And I'll plug these values of x and y in. So we get 2.8 squared plus 0.4 squared. Hopefully this will work out to the right hand side, which is 8. So we have 2.8 squared plus 0.4 squared. So it does check out. Now I'm going to check this other pair. X equals 2, y equals 2. So I'll write out the left hand side of our linear equation. So we have 2 times 2 plus 2. Okay, we just plug 2 in for x and 2 in for y, and that gives us 4 plus 2, which is 6. So that does check out. And over here we have x squared plus y squared equals 2 squared plus 2 squared. Well, that's equal to 4 plus 4, which is 8. So it checks out. Here we have a graph of the line 2x plus y equals 6 and a graph of this equation here. This is actually the equation of a circle. It's shown here in two different sections, but it's just one continuous circle, of course. It's a circle that's actually centered at the origin, and its radius is actually the square root of 8, but that's for another section. What I want to show here is the intersections of both graphs. Here's the point 2, 2. It's the pair of numbers that satisfy both equations, so it's on both graphs. So it's the intersection of the line and the circle. And here's the point with coordinates 2.8, 0.4. Now in this section on the coordinate geometry of the circle, we will cover this type of question again, but the wording will be quite different. We'll be looking for the intersection of the line 2x plus y equals 6 and the circle x squared plus y squared equals 8. The wording is different, but the method is identical. So you will see that a line crosses a circle at most 2 points. Sometimes it just touches a circle at 1 point. In that case, the line is a tangent to the circle. So this is one example of solving between a linear and a nonlinear equation. Of course, the nonlinear equation doesn't have to be a circle.